Yes, hello, hi, welcome back. Welcome back to EDUHUNT IIT Foundation classes. This is Sukumar, your chemistry mentor. See, this is 6th class foundation chemistry, and we are in this chapter called Elements, Ions, Symbols of Elements, Ions and Formulae. And in the previous video, we just completed the topic called Valency, combining capacity, right? I hope you understand this. Now in this particular video, I'm going to add one more term to your knowledge regarding the valency only, called variable valency. Variable valency. Okay. See, the name itself gives an idea about this. What is this, right? Because you already know what is valency. You already know what is valency because we completed that part. Okay. Now, what I am saying, variable valency. See what this means? Valency is varying. Valency is changing, right? Yeah. Previously, what I told you, a element has a valency. Valency means, I think any one of you might know. See, I think you are not supposed to forget, right? What is valency? Valency is the combining capacity. Now, what is the valency of carbon? Valency of carbon is 4. That's why carbon combines with 4 hydrogen. Carbon combines with 4 chlorine atoms, like that, right? Yes. What is the valency of oxygen? 2. That's why oxygen combines with 2 hydrogen, 2 chlorine. Yes. Okay, fine. But the point is, some elements, I am writing, okay? Some elements means atoms of an element, okay? Some elements shows more than one type of valency. More than one type of. Okay, some elements. Sir, what are those elements? Why that elements are showing more than one type of valency? We are going to discuss it further. But wait, some elements shows more than one type of elements. Sir, what about other elements? Yeah, we completed that. So generally from the previous class, we got an idea that every element has a fixed valency. If carbon has valency 4, that is a fixed thing, like that, right? But there are so many examples. There are so many examples in which an element or the atom of an element can show more than one type of valency. Okay, let me give you example for that first. Let me give you examples for that. First one is FeCl2, FeCl3. So, look at that carefully. What happened there? Here, iron combined with 2 chlorine atoms. Yes, by looking at this example, FeCl2, anyone can say that the combining capacity of iron here is 2, right? Valency is 2. The combining capacity of iron is 2. Then, look at that example, FeCl3. Now you can say that the combining capacity of iron is 3, right? Yes. So what is this? Here the same iron the same iron is showing more than one type of valency, Fe, right? Yes. Then why, sir? Why is that happening, sir? Yes. See, generally an atom will lose electrons in the outermost shell. Outermost shell. Generally. See, in the previous video, I explained you how to identify the valency. There, I explained you one point. The number of electrons lost, right? Or the number of electrons gained, or the number of electrons shared to form a bond, right? That is the valency. So here what happening, iron is going to lose electrons to combine with chlorine. Okay, if that is the case, then here what happened, iron has lost 2 electrons. Iron has lost 2 electrons in the first case, and in the next case iron has lost 3 electrons, right? Yes. Why? How? Fe, iron, if iron lost 2 electrons, Fe2 plus, it will become 2 plus by the release of 2 electrons. Okay, fine sir. Now next case what happened? Fe, iron has lost 3 electrons, it will become Fe3 plus, right? So the first one is called ferrous ion, Ferrous, ferrous ion. The next one is called ferric ion, Ferric, ferrous, ferric. Okay, see, generally this is the charge you are seeing, right? This is charge, sometimes called oxidation state. Yes, the point is, if it is in lower, number, compare it to the next one, then the name ends with us. If it is higher, the name ends with ic. Ferrous, ferric, cuprous, cupric, phosphorus, phosphoric. So generally you have to observe this in the further upcoming examples also. Okay, if this charge is lower, the name generally ends with us. If this charge is higher, charge is nothing but it is nothing but oxidation state. You are going to learn it in the upcoming topics. So this is ferrous ion, ferric ion. So the same iron is going to show more than one type of valency. Now the reason, what's the reason behind this? The reason behind this, some metals, okay, generally atom will lose electrons from the generally atom will lose electrons from the okay, now that's looking better. Generally atom will lose electrons from the outermost shell. This is the general fact. Okay, but some metals, I'm saying metals, okay, some metals can lose electrons more than electrons from outermost and the shell behind it also. The shell behind the outermost shell. Okay, the shell behind the outermost shell is called penultimate shell. We are going to learn it later. Penultimate shell. I'll explain what happened here. See, I'll explain everything what happened here in clearly. You take an example of calcium. Okay, now you know that calcium has an atomic number of 20. It means what? Calcium has 20 electrons. Now you may know or may not know how to write the configuration. That means how to write these 20 electrons. Okay, how to arrange the 20 electrons in an atom, but I am writing for you. Okay, yes, like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now count the number of electrons. Now count. See, this is the first shell, second shell, third shell, fourth shell. Okay, you may not know how to write this arrangement. You are going to learn this in the upcoming chapters. For now, I am writing for you. You just focus on my explanation. See, you know, in any atom, at the center there is nucleus, right? At the center there is nucleus. Around the nucleus there is a shells. In that shells, electrons are revolving. That much you know, na? Yes. These are the shells. First shell, second shell, third shell, fourth shell. This fourth shell is the outermost shell. Outermost shell. So otherwise called Valency shell. This is outermost shell. Outermost shell or Valency shell. Okay? Outermost shell or Valency shell. Or otherwise called ultimate shell. Outermost shell is otherwise can be called as ultimate shell. Why? Because this is the shell from which electrons participate in bonding. The outermost electrons are generally important. How many electrons? 4s is the orbital. Okay. There are 2 electrons. 1, 2, 3, 4 plus 4 plus 6, 10. 10 plus 2, 12. 12 plus 6, 18. 18 plus 2, 20. That's how these 20 electrons we arrange. So, this is the outermost shell or ultimate shell. And the shell behind this is called penultimate shell. Penultimate shell. Okay? Yes. So, generally what happens for a metals or non-metals or any examples, generally atom will lose, if the atom is going to lose electrons, because you know, to combine with other atoms, sometimes atoms has to lose electron, sometimes atoms has to gain electron, sometimes atom has to share electron. But now I am taking the only first case. If the atom has to lose electron, generally the electrons from the outermost will be lost. Generally, that's what I wrote here. Generally, atom will lose electrons from the where? From where? From the outermost shell, generally. Okay. Outermost. In the calcium outermost shell, how many electrons are there? 2 electrons are there. Now, then what happens? Calcium is the atom. If it lost 2 electrons, Ca2 plus by loss of 2 electrons. Yes, by losing these 2 electrons, now if these 2 electrons are released, then there is no shell. No electrons means no shell. Now erase this. Now erase this. No electron means no shell. Then what happens? Then the outermost shell becomes this shell. Now how many electrons? 2 plus 6. How many electrons here? 2 plus 6, 8 electrons. I told you, generally an atom will lose electron or an atom will gain electron or an atom share electrons to get stability. And I explained what is stability generally. Having a stable arrangement of electrons in the outermost shell gives the stability, I told you. And what is the stable arrangement? I told you in the previous video. Having 8 electrons in the outermost shell. Having 8 electrons means octet configuration. Yes, this is the octet configuration. NS2, NP6. This outermost shell can be 3rd shell or 4th shell, 5th shell or any shell depending upon the example we have taken. But in the outermost shell, if there is 8 electrons like NS2, NP6, that is octet configuration, that will give stability. Okay, sir. Fine, sir. Now, what is the valency of calcium? In the calcium is going to lose 2 electrons to combine with other atoms like chlorine. Okay, like chlorine. Now, what chlorine will do? Chlorine atom want to gain 1 electron to get stability. Now, if chlorine atom gains 1 electron, it will become Cl minus. Sir, why? What, sir? Here calcium has released 2 electrons, but chlorine is gaining only 1 electron. Yes. Then what you will do? You take 2 chlorine atoms and use that 2 electrons so that you will get 2 Cl minus ions. Now, add these 2 steps. Sir, how to add the steps, sir? Yes, I explained in the previous video also. First, arrow mark, make an arrow mark at the middle. Now, what you have to do? You have to add the reactants. That means the species in the left hand side. all the things in the left hand side must be added and right here. And all the things in the right hand side must be added right here. But the point is, if the things diagonally common, you have to cancel. See, 2 electrons released in the first step and consumed in the next step. First step lo release ayyayi, next step lo absorb అయిపోయాయి. కాబట్టి ఫైనల్ గా ఉండవు. కాబట్టి డయాగోనల్లీ కామన్ గా ఏమైనా ఉంటే క్యాన్సిల్ చేసేయాలి. యూ హ్యావ్ టు క్యాన్సిల్ ద కామన్ టర్మ్స్ డయాగోనల్లీ. నౌ Ca plus 2Cl. Ca plus 2Cl I am writing as Cl2. Actually that exists like that. And CaCl2. Ca2 plus Cl2. CaCl2. This is how the compound is formed generally. Okay. And what is the valency of calcium here? Yes, in the process of combining with chlorine or any other element, calcium is going to lose 2 electrons. So the number of electrons lost by an element, okay, during the formation of bond is called valency, combining capacity. How many electrons lost? 2 electrons. So the valency of calcium is 2. Then what is the valency of chlorine? 1 chlorine atom, 2 chlorine atoms gained 2 electrons. Then 1 chlorine atom gained 1 electron. So the valency of chlorine is 1. So the combining capacity of calcium is double the combining capacity of chlorine. That's why 1 calcium combined with 2 chlorine. Okay, fine. But the point here is the combining capacity, valency of calcium is fixed. Valency is equal to 2 only always. 2 only always. Okay. But calcium is a metal. But the combining capacity, alkaline earth metal. Yes. But the combining capacity of calcium is fixed. But that is not the case with all examples. There are some examples, some metals which can lose electrons, which can lose electrons from outermost and the shell behind it also. They will lose electrons anyway from the outermost shell, but along with the outermost shell electrons, they can lose the electrons from the shell behind it. What is the shell behind the outermost shell? Penultimate shell. Okay, I will take an example, the same example iron I will take and explain why it happens and how it happens also. See, you know what is the atomic number of iron? Atomic number of iron, Z is equal to 26. It means what? You have to arrange 26 electrons in the atom of iron around the nucleus. What happens? See, if this is the nucleus and around the nucleus there are first shell, second shell, third shell, fourth shell and so on. Okay, and what you need to do? You have to arrange 26 electrons in these shells. Okay, in the upcoming classes, like when you learn the periodic table complete chapter, you are going to write how to arrange the number of electrons in an atom. But now I told you, I am going to write for you. Okay, I am going to write how to arrange this 26 electrons. Okay, you may not know this, no problem. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, again I am telling you, please don't worry if you are not completed learning how to write this electronic arrangement, electronic configuration. You are going to learn it further. But to explain the variable valency, I am writing it for you. Okay, yes. Now, what are the electrons? This 2. Okay, 1, 2, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 6, 24, 24 plus 2, 26, a total of 26 electrons. And what are the respective shells? First shell, like this, first shell, second shell, third shell, fourth shell. Okay, now And generally you can call the outermost shell. This has the outermost shell. The shell is at the ending, the outermost. That means you can define this outermost shell as the shell which is far away from the nucleus, the most far away. Okay? Yes. This is outermost shell, or otherwise called valency shell also, the name. Outermost shell. And the shell behind is the penultimate. Penultimate shell. So ultimate, penultimate. Outermost, penultimate. Okay. See, if the outermost shell number is n, then this will be n minus 1 shell. This is n minus 2 shell. Like that you call. Because the shell number is 4, na? Here shell number is 4. If the outermost is 4, then the shell behind will be 3. So 4 minus 1, 3. Like that. This is the kind of this is the way of expressing the electronic arrangement in an atom. But usually in the case of calcium, what you studied, calcium also has 4s2. Calcium also has 4s2, but 3d is not written in the case of calcium because 20 electrons only. Okay. Now what happened? Calcium only lost electron from the outermost. Here calcium has that 4s2, na? So calcium has lost only these 2 electrons. This is the 2 electrons. Okay, and only the electrons from the outermost shell. But here what happens? Here some metals, I told you, some metals. Which metals are? Yes, the metals in which there is this incomplete d subshell. This is called subshell. When the penultimate shell has this d electrons, d 3d, 4d, 5d, like that. Then what happens? This atom can lose electrons. Okay, electrons from the outermost, from the penultimate shell also along with the outermost. That means these 2 electrons anyway it can lose. But along with it can lose 1 or 2 electrons, 1 or more electrons from this d subshell also, depending upon the requirement and examples. Then iron, this is the electronic arrangement of iron. Now imagine, what if iron lost only in the outermost electrons? Then it will become Fe2 plus 2 electrons. In this case, we called iron as ferrous. Ferrous. Okay. Now, what another possibility? Yes. What if iron lost electrons from the outermost and 1 electron from the 3d also? Then these 2 electrons plus 1 electrons, it can lose 3 electrons. Yes. Okay. Will become Fe3 plus. Fe3 plus by releasing 3 electrons. So some metals can lose more number of electrons. Okay. Can lose the number of electrons more than the electrons present in the outermost shell. So in the outermost shell of iron, only 2 electrons present. But iron has lost 3 electrons. Where that extra 3rd electron came? That electron came from the penultimate shell. This is how some metals can show a variable valency. And it is not the case like only metals show variable valency. Non-metals also can show variable valency, right? Non-metals also. I'll give some examples like, see, you can see PCl3, phosphorus trichloride. Here, phosphorus combined with 3 chlorine atoms. But there is example like PCl5 also. PCl5 also. Yes. SO2 sulfur dioxide. See, similar way, SO3 sulfur trioxide. That means the same sulfur atom is showing more than one type of valency. Okay. What is the valency of sulfur here? You can determine with the old example also, because it combined with oxygen. What happened? Sulfur combined with 2 oxygen atoms. Double the number of oxygen atoms. See, in the old way of determining valency, what is the definition? The number of atoms of hydrogen or the number of atoms of chlorine or double the number of atoms of oxygen with which an atom can combine is called combining capacity, right? Here sulfur has combined with 2 oxygen atoms. So 2 into 2. Here the combining capacity of sulfur is 4. And here the sulfur combined with 3 oxygen atoms. So 2 into 3. Here the combining capacity, that means valency. Valency of sulfur here is 4. Valency of sulfur here is 6. There Here phosphorus combined with 3 chlorine atom. Valency is 3. Here valency is 5. Okay. Do you remember the old or basic definition of understanding valency? I explained that in the first video. Okay. Yes. I hope you understand. Let's see the few examples.